presenting online class. Now it is time for us to study physics. Yes, we have done a lot of work in mathematics. Remember, in this platform, in this online class, we are interested mostly in science subjects, especially physics and mathematics, to do what? End science and math phobia. Good. We are working on dimension of physical quantities. Of course, apart from the fundamental and derived quantities and their units, the knowledge of that, there is also what we call dimension of physical quantities. That simply means expressing the physical quantities and their units in terms of what? Basic fundamental units of what? Mass, length, and time. So when we now quantify or express the physical quantities, symbolizing in terms of what? In the dimensions or in terms of the quantities of the fundamental quantities of what? Mass, length, and time. That is MLT. We refer that to as what? Dimension of physical quantities. Okay, because all the derived quantities are derived basically from the word fundamental physical quantities and their units by simple combination of either multiplication or division arithmetic upon the quantities and their units. Now join me, let us look at this. Find the dimensions of acceleration, work, density, momentum, pressure, and a whole lot of them. We have a lot of them, a lot of derived quantities, even velocity, even force, even energy, power. Yeah, all these are derivable, but we are working on this. Perhaps after this you'll be able to tackle the rest, and I can even give you a task here. Join me. Now look at this. In solving this, we have first acceleration. Number one is acceleration. First of all, you remind yourself, what is the formula for acceleration? Acceleration is increase in velocity over time. That gives us acceleration. That is A is dv over t, increase in velocity over time. That's acceleration. And what is the unit of acceleration? Unit is meter per second square. The unit of acceleration is meter per second square, or sometimes they write it this way, meter per second square, all the same. Now, having known this, which is increase in velocity over time, from the unit now, we can easily transform it into a fundamental of MLT dimensioning. Yeah, we are now having that will lead us to our M here stand for what? Meter, and meter is what? Length. Of course, we have length. Then our S here stand for what? Time, which is the unit of time is seconds. Unit of distance is meters. That is standard unit, the SI unit. Then that is standard, the international unit. Then the unit of mass is kilogram. So the M here is not mass. The M here is meter, length. Then S here is time in seconds. Then whenever you see kg, it is mass, which is capital letter M. That's what this symbolize. M here is for mass. Then L here is for what? Length. T here is for what? Time. So here I have M is L. S here is what? T. Then raised to power minus 2. Simple. So this is the dimension of what? Acceleration. Then II, work. For work, then work is defined as the product of force and the distance or displacement moved in the direction of the word force. So by analysis, work is equal to what? Force times distance, or force times displacement in the specified direction. Now, if this is the case, what is the unit of work? The unit of work is Newton. Sorry, the unit of work is joule, of course. The unit is joule. But we are not working with this joule. We transform this joule into this derivative or into this derivation of force times what? Distance by the basic fundamental unit of it. Of course, joule is a honorary unit for somebody's name. So we don't use somebody's name in what? In dimension. We now transform it back to its original unit derived from the quantity. So force, of course, we know that force is Newton. Of course. So this joule should be Newton meter. In other words, it should be Newton meter. Newton meter. Reason. Force is Newton. Distance here is what? Meter. But we are not working with somebody's name as well. We go back to the basic. Now, force here should be, remember that force is mass times acceleration. Force is mass times acceleration. So force being mass times acceleration is like having a mass is kilogram. So we have here kilogram. Acceleration is what? Meter per second square. So kilogram meter per second square. There's a distance here. This distance is also meter times what? Meter. That is what we have. Times meter. You see how we transform this? So force is kilogram meter per second square, which is force is mass times acceleration, and the mass is kilogram. Acceleration is meter per second square. Then there's distance here. This distance is what? Meter. Good. So from this now, it will become, the kilogram is for mass, which is this m. You must use capital letters for that dimensioning, like I did here, uppercase letters. Then the meter here is for length. Then you see per second square here means t raised to power minus 2. In other words, 1 over t squared. Then times meter here is what? Length. So this will transform into m. L times L, you have L squared. ml squared t raised to power minus 2. Simple. So this is dimension for what? Work. Because kilogram is mass, meter here, length, per second square means t raised to power minus 2 times the total distance from here, first and distance. So have this. So L times L, L squared. So ml squared t raised to power minus 2. Very good. Then number 3. Number 3 says density. Wow. Density simply is given by rho is equals to mass over volume. Because you should know the formula, the derivatives. Then density is mass over volume. Of course, by unit, density will become, unit is, mass is kilogram, then volume, that's slash m cube. We are working with standard units of these quantities, which is, or you write it this way, but I can write kilogram per meter cube. So that unit of density, kilogram per meter cube. So from this unit of density now, we can simply do our work. We have here, kilogram is for mass, like I told you, that's capital letter M representing it. Whenever you see kilogram, you represent with capital letter M in dimension of physical quantity. Whenever you see distance or displacement, you represent, which is what? Small letter m, which is meter. You represent with what? Uppercase what? L, capital letter L. Whenever you see seconds, not S, whenever you see seconds as a unit, we are working with unit, but by formula, S is what? Distance. But by unit, kilogram, in fact, to make it easy, always operate with the unit. So kilogram is for m, that's the mass, meter is for L, and the seconds is for what? T. Simple. That's the transformation. So kilogram here is mass. Then kilogram is mass. Then have per meters cube. So meter here is length. Then now put the quantity, the unit as is, raised to power minus 3. raised to power minus 3. Simple. So what we have is what? M raised to power minus 3. Then momentum is mass times what? Velocity. Then pressure is force over what? Area. Okay, quickly, let's work out of momentum here. Momentum. Good. For number 4, for momentum is given as momentum. So momentum is given as particle momentum P equals to mv. That is mass times what? Velocity. So having known what mass is and what velocity is, we can work that of what? Momentum. Of course, momentum is velocity is displacement over time. So what is the unit here? For unit of momentum, the unit is mass is what? In a kilogram. Then velocity is meter per second. I think you can solve this easily. It's very simple. So meter per second, you can solve it very simple. Then for that of, I'll just give you guides to this. You are going to finish it yourself. Yeah. For that of, so with this now you can solve. You can complete this. For that of V says pressure. For pressure is given as P. This is particle momentum equals to force over what? Area. And of course, we can now see that pressure, the unit will be, for pressure, the unit is, force is Newton, and area is meter square. So Newton per meter square. And this will be equivalent to Newton is kilogram, because force is mass times acceleration. So kilogram meter per second square, then times meter, that's times per meter square. That's kilogram meter per second square for force, then times per meter square. So it's like saying over meter square. You see what it means? So this is simple. Okay, let me finish it up. For this one quickly, it is not difficult. Of course, at this point, for this one, for momentum, particle momentum, kilogram is mass, meter is L, time is this, power minus 1. Very simple. Let me finish it for you. I'll still give you a task. Then for this, you have a pressure now will be equal to, like say, kilogram meter per second square all over, or let's make it working with directly like this. Kilogram is already m, then meter is L, then time here 10 raised to power minus 2, then times meter again L raised to power minus 2, and that will give us m L 10 raised to power minus 2 all over L times L, because this is L raised to power minus 2. Remember, in indices, raised to power minus means 1 over. So when you have this now, finally you have m, then L will kill one L here, remaining one L. M T raised to power minus 2 over L, because one L will go out here when this one goes. Finally we have M L raised to power minus 1 T raised to power minus 2. This is for pressure. Very interesting. See what we did here. We have ml to the power minus 2, that is kilogram meter per second square, times per meter square, that's m to the power minus 2. So L to the power minus 2. So when you come now, this minus 2 means over, inverse. So ml here, t to the power minus 2 all over L to the power 2. Then one L will cancel one L, remaining one L at the denominator. Then when it comes up here, it means what? Raised to the power minus 1, because L to the power minus 1 means 1 over what? L. L to the power minus 2 means 1 over L squared. So these are the things that will help us understand these things. Thank you so much for paying attention to this class. Of course, I would like you to try some. I would like you to try this. Having understood this, I would like you to try this. Try this. The dimension of velocity, the dimension of maybe help find the dimension of velocity, find the dimension of power. So try this too. Of course, you know that power is work done over time, or energy over time. That is power. So try these two, velocity and power. Then drop your answer in my comment box at Joe Newton Online Class Facebook page and the YouTube World page as well. Thank you for paying attention to this class. For more of this, visit my YouTube page. My YouTube